Hello everyone, in this video we'll learn how to solve Lagrange's linear partial differential equations using method of grouping. The first order linear partial differential equations in the standard form is given by P into P plus Q into Q equal to R, where capital P, capital Q, capital R are functions of x, y, z or constants, and small p and small p is nothing but dou z by dou x, q is dou z by dou y, and the first order linear partial differential equation is called Lagrange's linear partial differential equation. For example, if you look into this, p into tan x plus q into tan y equal to tan z. Here capital P is tan x, capital Q is tan y, and capital R is tan z. Similarly, in the example 2, capital P is x, capital Q is y, and capital R is y square minus x square. Here in the third example, capital P is 1, capital Q is minus 1, and capital R is log of x plus y. Now we'll move to the working procedure to solve the Lagrange's linear PDE. First of all, we have to put it in the standard form if it is not in the standard form, and identify what is P, Q and R. In step 2, we'll be writing the auxiliary equations or subsidiary equations. Dx by capital P is equals to dy by capital Q is equal to dz by capital R. To solve these auxiliary equations by method of grouping, or we can also solve by method of multipliers, but in this video we are learning the method of grouping. So we look for two independent solutions. Say u is equals to a is one independent solution and v is equals to b is another independent solution. So then the general solution is given by f of u comma v equal to 0 or u equal to some function of v. Let's remove the method of grouping. So in the method of grouping, we'll consider the two ratios, either first second, second third, or third first from the auxiliary equation. Suppose if I choose first and second, we should be careful that either the z is absent or z term is get cancelled out. Then by using variable separable method, we get one independent solution. Similarly, if I choose second and third ratios, either x is absent or x term is get cancelled, and by integrating that we get another independent solution. We get another independent solution. Similarly, we can consider first and third, where y term is get cancelled or y term is absent. So overall we require two solutions. Then the general solution is given by f of u comma v equal to 0 or u equal to some function of v. Now we'll solve some problems. In the first problem, we have solve the linear PDE y square z into p plus x square z into q is equals to y square x. Here the subsidiary equations are given by dx by y square z is equals to dy by x square z is equals to dz by y square x. Here we consider the first and second ratios. Dx by y square z is equals to dy by x square z. Here the z term is get cancelled, and by separating the variables we get x square dx is equals to y square dy, or I can write this as x square dx minus y square dy equal to 0. Now integrate both sides. So we get here x cube by 3 minus y cube by 3 is equals to some constant. I'll take it as c1 by 3. This is x cube minus y cube is equals to c1. This is my first independent solution. Now I consider first and third ratios. Dx by y square z dz by y square x. Here y square and y square will get cancelled, so we get x dx is equals to z dz, or x dx minus z dz equals to 0. Now on integration we get here x square by 2 minus z square by 2 is equals to some constant c2 by 2. So we get here x square minus z square is equals to c2. So general solution, I write as gs is function of first solution, that is x cube minus y cube x square minus z square equals to 0. Here I have not considered this second and third ratio because I cannot cancel out the x. So here we got the two solutions, and we can write the general solution. We move to another one. Sometimes the first solution is used to get the second solution. Here is the example: dx by 1 equals to dy by minus 1. Implies dx equals to minus dy or dx plus dy equals to 0. On integrating, we get x plus y is equals to c1. Now I can consider first and third ratios or second and third ratios. So I'll go for first and third. Dx by 1 is equals to dz by log of x plus y. Now we cannot separate the y from here, so we use the first solution to get the second solution. This is dx equals to dz by log of c1. So for integrating, we get x so x equals to z by log c1 plus c2. Or I can write x minus z by log of c1. I can write back as x plus y is equals to c2. So now I'll move to the general solution. General solution is function of first solution, that is x plus y, over second solution x minus z by log of x plus y equals to 0. Now here, in this example, we consider the first and third ratios dz by y. Y term will get cancelled here. We get here x dx equals to z dz or x dx minus z dz equals to 0. So on integrating we get square by 2 minus z square by 2 is equals to c1 by 2 or x square minus z square is equals to c1. Now here I can consider first and second or second and third. So I'll take the first and the second. Dx by yz equals to dy by xz. Cancel out the z term, so we get x dx equals to y dy or x dx minus y dy equals to 0. So on integrating we get here x square minus y square is equals to c2. General solution x square square minus z square is some function of x square minus y square. Now we'll move to another example. Here the subsidiary equations are given by dx by x square minus yz equal to dy by y square minus zx equals to dz by z square minus xy. Here we cannot cancel out the third variable, so here we consider dx minus dy by x square minus yz minus of, well, multiplies minus, so minus y square plus zx is equals to dy minus dz by y square minus zx minus z square plus xy. Now here we do dx minus dy x square minus y square minus z is common, or I can take plus z common, x minus y. Similarly here dy by dz by y square minus z square here we take x common, we get y minus z, or I can write this as dx minus dy by x minus y common in the denominator, so we get x plus y from the first term and plus z from the second term. So this is dy minus dx, dy minus dz, y minus z, x plus x plus y plus z. So y is plus z from the first term and x from the second term. So this term will get cancelled. This is nothing but d of x minus y by x minus y is equals to d of y minus z by y minus z. So on integrating we get log of x minus y is equals to log of y minus z plus log c1, or I can write x minus y by y minus z is equals to c1. Similarly, if I consider the second and third ratios, that is difference of the second and third, dy minus dz by y square minus zx minus z square plus xy is equals to dz minus dx by z square minus xy minus x square plus yz. So we get second solution as y minus z by z minus x is equals to C2. So this is my first solution and this is my second solution. Then I can write the general solution. So thanks for watching this video. If you like the video, subscribe and share it with your friends. Thank you.